So this question is quite a complex one when you first see it and you see all the diagrams, but it's about trying to kind of understand what the question's actually asking you to do. So it starts off with some trigonometry, and then it goes into some probability at the end there. So it's all based around this wind turbine that we can see here, and you're given all of the measurements and you're told about it here as well. Okay, so it's 90 meters above the ground, and each blade measures 40 meters. And this point C, as the wind turbine rotates, obviously the place that point C is will change, and therefore the value of H will change as we go round, so how far it is off the ground. So the first question there is asking us to work out the maximum value of H. So we can see that that's going to be where the turbine is exactly at the top, and therefore it's going to be 90 plus the 40. So 90 plus 40, and that's going to give me 130 meters. And then for the minimum, it's going to be 90 minus the 40, and that will give me 50 meters. Okay, so that's this value if it was right down here, so it's the 90 minus the 40. And then we're told that the blades of the turbine complete 12 rotations in every minute. Okay, so every minute this goes round once, twice, and so on 12 times. And we're trying to work out how long it takes to make one complete rotation. So given that there are 60 seconds in a minute, I'm therefore saying it's 60 divided by those 12 times, and that will give me how many seconds it takes to do one rotation. So it's going to take 5 seconds to do that one rotation round. So essentially you're saying 5 times what gives me 60, okay? Or 12 times what gives me 60. So it's 5 seconds each. And then calculating the angle in degrees that it therefore goes in every 1 second. So if it takes 5 seconds to do a full rotation, then every second it's going to take 360, which is the full circle, divided by 5. That's how many degrees it's going to go. So that each time, 5 times over that period, it does the full circle. So for this one, it's 360 divided by the 5 seconds, and that tells me that I rotate 72 degrees every second. Okay. So the next part is then using it as a model. So they've given you this model of the function, and we need to write down the amplitude. So one way you could do this is just by sketching on the GDC, but equally we know that the amplitude of a function is the number in front of the cos or sine. Okay, so in this case it would be 40, which is the amplitude of the function. Okay, so it's always the kind of a sine x, it's that a part. And then the period is always 360 divided by, and then it's the number in front of the x value, or in this case t. So it's 360 divided by 72, and therefore the period is 5, which makes sense because it goes 5 times or every 5 seconds. Okay. And we need to sketch the function on the GDC. Okay, so you won't be expected to do this by hand. So on our GDC, we can go to our graphing software, and you want to make sure that this is in degrees, not radians. So if it's in the wrong one, we can just go to Menu, Settings, and then you need to make sure that the graphing angle is also in degrees. Okay, otherwise you're going to get the whole question wrong. So we're going to need to write in our equations. So it's 90 minus 40, and then cosine is found in the trig button, and it's 72t, and we need to change the t to x. Okay, so this is what we're plotting, and we're plotting it for t between 0 and 5. So we want this to be 0. I'm just going to put -1 and to 5. And then we need to change the axis here. So we could go to 100 maybe. Okay, now we can start to see it. Maybe we need to go a little bit more again. There we go. So it's from 0 to 5. So it looks like that would be a minimum point to a minimum point. Okay. So to be able to label everything in your exam, you need to find what the maximum and the minimum points are. So analyze, there's a maximum point over here, and then there's a minimum point. Yeah, and that looks to be exactly where it crosses the axis as well. So we don't need to find that part. And we've got another minimum this side, which I can't really see. Let me move that along a little bit. There we go. So let's find the minimum point is, yeah, it's also at 5. Okay, so it is at the two ends. So in your exam, if we go back to the exam paper, you're going to be sketching that out. So I'm just going to do it over here. So you've got your axis, and it starts around here at 0.50, which you would need to label. It goes up and then back, and it finishes at 5.50. So you would need to have the coordinates labelled, including the maximum here, which was 2.5130. Okay, so everything needs to be labelled on your axis. And then part E is to find the height of C above the ground when T is 2. So if we go back to our GDC, it's when T is 2. Now the easiest way of doing this is Control T. It brings up our table of values, and when T is 2, the height is 122.361. So it gives it straight away there. So that's probably the easiest way to do that one. If not, then you could substitute in when x is 2, when x or t is 2. Okay, so you can either substitute it into your formula, which would give you 90 minus 40 cos 72 times 2, or you can just choose your GDC. You'll still get the marks for writing the answer on its own, and it's 122.36 that we can see there. Okay, so you can either do it this way or just writing the answer. And then we need to find the time in seconds that it takes of when it's above the 100 meter line. So again, going back to the GDC, let's get rid of the table, so Control T. And if I press Tab, I can now draw the line of 100. And we can see that it intersects twice there. So we can do Analyze Graph, Intersection. So there's one intersection at 1.45, and then there's a second intersection, which is at 3.55. So 1.45 and 3.55. So the whole time between 1.45 and 3.55, in between here and here, the graph is above 100 meters. So essentially I've drawn on, and this whole time in the middle, that whole range of time, it's above 100 meters. So therefore, if I do 3.55 subtracted by 1.45, then that will tell me how long that happens, which is 2.1. So for every 2.1 seconds, or for 2.1 seconds, then it's above 100 meters. And then looking through this window, we're only able to see when it's less than 100 meters. So we can't see that part where it's above 100 meters at all. And we're trying to find out at any given time the probability that point C is visible through the window. Well, this is leading on from part E. So we just found that for 2.1 seconds, it's above 100 meters. And therefore the probability is going to be how long it's above the, it's the probability that it is visible. Okay, so is visible 5 minus 2.1 of the time out of the 5 seconds it takes to turn round. Okay, so it's 5 seconds to turn round, and the probability that it's below is 5 minus 2.1. It's the opposite of what we've just calculated. Okay, and that gives us the answer of 0.580. So 0.580. And then it says that the wind speed increases. So the blades are now rotating faster. And again, we need to find out the probability that he can see point C through the window. Well, even if the blades are going faster, the probability is going to stay the same, because it might go twice as fast, but that just means that there's 2 lots of that time that it's going above. Okay, so the actual proportions aren't changing at all. So it's still 0.580, and it's because the proportion hasn't changed. So changing the frequency won't change how often it's at the top of the wind turbine compared to at the bottom. Okay, so it hasn't changed that at all.